All right, example 6, we're going to prove the identity. And it makes a note here because when you first look at this problem, it's like, well, they both have a single term and then they both have a binomial. So, but the extra terms in the denominator on the left-hand side are going to make it more complicated, okay? We could decompose the expression on the right-hand side. But the fact that it's a 1 minus sine t, it's connected together in the denominator, is going to make it tougher. So what can we do here? Let's work the left-hand side. And so that 1 minus sine of t. And so I'm thinking, one of the things is when we factor, we know that's half of that difference of squares. So what if I multiply it by its conjugate? And so if I multiply this denominator by its conjugate, the 1 plus sine of t, we know what we do to the bottom, we have to do to the top. Oh, and look, that's actually what I needed in the top, isn't it? So that's a good thing. All right, so since I needed this in the top here, I'm not actually going to distribute that cosine of t on top. So I'm going to leave this. I'm going to put the cosine of t in front because it's my single term, times the 1 plus sine of t over. Now, I don't need a sign in the denominator, so I'm going to go ahead and multiply. But I know that I've got 1 plus sine of t and 1 minus sine of t, so this is a difference of squares. So when I do my first, I'm going to get 1. I know my outer and my inner will cancel on a difference of squares, and so my last is going to give me minus sine squared of my variable. Now, let's see. The top, we still got that 1 plus sine of t there. We're not going to touch it. It's what I need in my answer. So I need to do something to the bottom. I have a 1 minus sine squared of t. How can I take that to a cosine? Well, I have a 1 and a trig function squared, which makes me think Pythagorean identities. So look at your identities, your Pythagorean ones. What is 1 minus sine sine squared? 1 minus sine squared is equal to cosine squared. So I'm going to rewrite my numerator here. Well, that's nice because I needed a cosine in the denominator as well. But notice you have a cosine on top and you got 2 on bottom. So we're going to take 1 away. So we get 1 plus sine of t over cosine of t, which is exactly what we were after. So equals 1 plus sine of t over cosine of t. Do you have to write it both times like this? Yes, you do. Okay, guys? And then you can put that QED if you want to say that we have demonstrated it.